Alright, in this video we're going to look at integrating using logarithms, and we've already done this a little bit where we looked at last semester. We took the derivative of the natural log of x, we got 1 over x, and I've mentioned to you that when we go the other direction, if we were to integrate this way, almost natural log of x, but we do need the absolute value sign, and of course you would need a plus c if you didn't have limits of integration. Okay, so questions 1 and 2 are really just recognizing that, recognizing this pattern and that you've got some variation of a number over x. So this guy, of course, you could write the 5 out front like so, and then you could get 5 times the natural log of the absolute value of x plus c. So if we were to take the derivative of this, we would end up with that, and so that's why that's the answer. So as long as there's no chain rule piece to it, 1 plus c, then it just fits this format and is fairly straightforward. So question 1 and 2 are really just kind of testing to see if you know this property. All right, and we've seen a little bit of rewriting things. So if you can do some algebra first, or some exponent tricks first, or fraction tricks first, then sometimes that's what you want to do. So looking at number 3, it does look a little bit harder. It doesn't look immediate what we should do, but let's go ahead and split apart our fraction. Okay, so remember, split apart numerators is fine, just don't try to split apart denominators. And then we could simplify this integration to the left, and it would leave something that's easy enough to integrate. And then this over here, you would have to know how to integrate with natural logs. So this would be 4 times the natural log of the absolute value of x. Okay, so if you can rewrite it in some way and that makes it easier, then you should do that. All right, and fortunately, unlike taking derivatives, we had to do chain rule, quotient rule, product rule, lots of practice with all those things. At least with integration, to undo those things, we just need use substitution. So on this one, notice if you just tried to pretend like it was question 1 or 2, and you did this, well, test it with taking the derivative. Taking the derivative of this would be that, but also times 2 because of the chain rule, and there's no 2 in here. So if it's something that simple, you could just see, all right, well, multiplying it by a half would undo the chain rule. And I guess you don't have to do the use substitution process, but the use substitution process would be fine. Okay, question number 5. If I did use substitution here, I would probably call this my u, because then my du would be 2x dx, which is almost x dx. So x dx is what I want. Divide the right side by 2, so divide the left side by 2. And then over here, this could be rewritten as 1/2 1 over u du. So that would be 1/2 natural log of absolute value of u plus c. Okay, and number 6, a good value to pick for u would be x to the 4th plus 3x. And I can see that so quickly because I can think ahead about what the derivative would look like. And the derivative would be these leftover pieces. So this would be the same as 1 over u du, which would be the natural log of the absolute value of u plus a c. All right, number 7, I would guess that the denominator is going to be u because its derivative looks pretty close to the numerator. So this is close to this. And I could modify what I have to what I want by dividing the right side by 3, so divide the left side by 3. Okay, so again, we're left with the how to integrate 1 over something, and that's where we need the natural log of the absolute value. So we've talked about that before, we've used it a little bit, but each one of these questions you can see has that involved. Okay, back up to number 8. I would probably pick out u to be the natural log of x because it's stuck under the square, which would make the derivative 1 over x dx, and then matching these things up, this looks like this would be u squared, and in place of 1 over x dx, I could put du. So raise to power by 1, divide by the new power, plus c, and our answer should not be in terms of u. So substitute this back in place of u. Remember, take the derivative if you have time as a quick check. Okay, number 9, there's a missing t there, that's important. But I'd probably pick the denominator to be u, because then the derivative would be cosine t dt. So that matches up with that. The other parts that I have are what I want, so I don't need to do anything to both sides here. So it looks like I could get 1 over u du, which would be the natural log of the absolute value of u. And I'm just plugging that guy back in. And don't forget your c. Okay, number 10. It's a little harder to think about what u should probably be, for me at least, but that's because I don't use this derivative too much. But the derivative of secant x is secant x tangent x. So assuming that you remember that one, and if you don't, then please put it at the top of your page. Make sure you review that. But if you know that one, then this is a direct fit here. This stuff is that. So I could replace this with 1 over u du. So the natural log of the absolute value of u plus c. Okay, so for those, as long as you know how to integrate 1 over x, the rest is stuff that we've done. We've got some pretty basic ones that just match up the property. We've got some where we did some exponent rules or fraction rules first, but then it fits the property. And then of course u substitution is fairly new to us, but it's exactly the same as what you practiced before. It's just that in the end we had lots of 1 over x's to integrate. So all right, and then on the next page, tangent identities. We've got 2 more tricks here. 11 and 12 is going to be one trick, and then 13, 14, 15 will be a different trick. So 11 is not really u substitution. I guess you could almost fit it to something you have memorized, but then you'd have to do chain rule in your head. So sometimes it makes sense to rewrite using your trig identities. So knowing like cotangent is cosine over sine, or in this case, knowing tangent is sine over cosine. So those quotient identities from pre-calculus. Make this, that's really your first step here, because there's not much else that you can do. Now I could pick u to be my denominator here. And this would be its derivative. Don't forget chain rule, and that's where the 1/3 is coming from. I match it up to this, compare these two. I don't want that 1/3 to be there. I want this. This is this. So if I'm multiplying this side by 3, multiply that side by 3. So this guy can be rewritten as 1 over u du times a 3. And so 3 natural log of absolute value of u plus c. And of course, if you have time, take the derivative to see that it works. Okay, so 12, since I've rewritten tangent as sine over cosine, I'm going to try to make u be this. And I'm not sure that this will be perfect, but I don't really know until I give it a shot. So the derivative of cosine something is negative sine something. But then chain rule, the derivative of e to something is e to something. And then chain rule again, so second chain rule, the derivative of negative x would be -1. And so I haven't made these substitutions yet, but it's looking like a great fit. Got 1 over u there in red, and this stuff looks to be a perfect fit for du. So all of this can be written as 1 over u du. So your answer should be the natural log of the absolute value of u plus c. So if it doesn't just fit the pattern, if you don't see any algebra, fraction steps, exponent steps, and u substitution doesn't seem to work out just right away, if there's a trig function like tangent or cotangent, you might consider using one of these quotient identities, because you can see that that helps it kind of fit together. All right, and then our last tip, or the last new type of question in here, 13, 14, and 15. So these kind of have a similar problem. I guess you could like factor this numerator if you wanted to. There's nothing wrong with that. But then there's just like nothing that cancels out. There's no exponent rules. I guess I could split this up into 3 integrations. Put this over x plus 1 and -3x over x plus 1 and 2 over x plus 1. And that might be okay. But really the way most people deal with these is with long division. So let me show you how that would potentially help you out here. If you divided this into this, x times x gives me x squared, x times 1 gives me x. You're subtracting this row, so change the signs. And then -4 times x gives me -4x. -4 times 1 is -4, but we're subtracting this row. Okay, so from long division, I can rewrite this as x minus 4 plus 6 over x plus 1. Remember, you have your quotient, which is x minus 4, plus your remainder over your divisor. That's how you deal with the remainder. Don't just do R6. And then that's quite a bit easier, because now I can just do these one at a time. Integrate x, integrate 4, and integrate 6 over x plus 1. And there you go. So I know long division sounds like it might be a pain, but you can see that by doing long division, rewrote it in a way that I could quickly do the calculus part of it. Okay, So what I'm going to ask on this one, on number 14, is if you would pause and try out the long division yourself to see where you get stuck, and then resume the video. Okay, so should have started off with an x squared, because an x squared times an x is what gives you x cubed. You also take it times -3, and since you're subtracting this whole row, I just changed the signs. So I am subtracting, I just like to distribute it right away. Those go away, and 5. So all of this becomes x squared plus the remainder over the divisor dx. Without the dx, it doesn't make sense. Make sure you keep that. Okay, so notice that wasn't the hardest long division. As long as you kind of consider long division quickly, it doesn't take very long, and then what's left behind is very easy to integrate. Raise the power, divide by the power, natural log of the absolute value of x minus 3, and don't forget your plus c after all of that work. Okay, for number 15, should work out similarly, but I would like you to again pause one more time and give it a shot. Okay, so our long division in number 15, you should just start it off with an x squared. So that would give you x squared times x squared is x to the 4th. X squared times 2 would be 2x squared. So you can put it here, but these aren't like terms, so don't try to force those together. You might choose to put it out here just to keep it easier. Okay, subtract all of this. So change the signs, those go away. Got this many x squareds, carry down the plus x, carry down the minus 4. Okay, go again. -2 times x squared is -2x squared. -2 times +2 would be -4. Subtract, so you change those signs, those go away, this goes away, and we're left with an x. So this would be our remainder. So from long division, I can rewrite this question as x squared minus 2, that's the quotient, plus the remainder, which was x over the divisor. Okay, and to integrate x squared, that's just undoing power rule, so you should be able to do that in your head. That part would be minus 2x. This part, you might want to do u substitution. Make the denominator your u, and your numerator is almost x dx, and it would be if you divided by 2. So divide this side by 2. So I want to be careful here. I want to do too much in my head. 1/2 1 over u du. That's how I wrote that. So plus 1/2. And then to integrate 1 over u would be the natural log of absolute value of u plus c. And I called u this. So you can kind of see in a longer question like this why I keep saying that plus c is probably the most forgotten thing. Because you get so involved in here, you just don't think about it. But make sure you have the plus c if you don't have limits of integration. All right, so just to recap, as long as you know this property, questions 1 and 2 just match that. Question 3 I got by splitting apart the fraction. 4 through 10, I had to know that property and do u substitution. 11 and 12, I threw in a trig identity so that u substitution would work. And then 13, 14, and 15, we did long division to rewrite it and make it easier. And only 15 needed u substitution. The other two kind of worked out. Okay, and that should be it.